Okay, so here I have an example equation. I've got a couple initial values here, so there's a unique solution to this equation. I've written out the first terms of it over here, and you can find those just by iterating it. So I want to look at some of the tools that we have now for this equation and see what kind of cool information we can find out about it. So this is the generating function. It's always going to be this rational function where a, b, and c, those are the coefficients here, 6, -5, and 1. And this generating function converges when absolute value of x is less than the lesser of the reciprocals of the roots of the characteristic equation. And this is the characteristic equation over here. These are the same a, b, and c. And then of course we have this relationship between the roots of the characteristic equation and the roots of the denominator of the generating function. They're just reciprocals, so this is the generating function here, the denominator a plus bx plus cx squared, that has the same roots as, well, the roots are the reciprocals of the roots of this equation here, which goes in opposite order. This one has power 2, power 1, power 0, this one has power 2, power 1, power 0. So one thing you might want to know would be what happens if you add all of the terms up. So you can see over here it's decreasing, so you have a chance of convergence. This is the same thing as looking at the generating function evaluated when x is equal to 1. So all we have to do to see if this is even possible to begin with is see is 1 in the radius of convergence. So I'm going to actually do it we have this relationship, but just to drive this point in, I'm going to actually calculate what is 1 over lambda here. So the characteristic equation for this one would be, so a is 6, so you have 6 lambda squared minus 5 lambda plus 1 is equal to 0. And if you wanted to solve this, there's a trick, you don't even need to use the quadratic formula. If you see that these numbers are in the opposite spots as you want them to be, so you just use a little substitution. X is 1 over lambda, or lambda is 1 over x, they're the same thing. And so what you can do here is this is just 6 times 1 over x squared minus 5 times 1 over x plus 1 times 1 over, oh crap, did I do this in the wrong order? 1, oh yeah, this is just 1. And then what you can do is you can multiply both sides by x squared, and you just get 6 minus 5x plus x squared is equal to 0. And of course this is the same as the denominator of the generating function here. You've got your a is 6, b is minus 5, and c is 1. So that's what you have here. And if you solve this, you see that x is equal to 2 or 3, which means that the, and remember these are the same thing as 1 over lambda, so that means that looking at this radius of convergence, it means that x must be less than 2, because 2 is the minimum. So the radius of convergence is x must be less than 2. And so this is fine, this is in the radius of convergence. So if you want to calculate this, all you have to do is plug it into the generating function here. And so if you plug this in, you just have to plug in the a, b, and c, the f0 and the f1. Up here, if you recall, I said f0 is 0, f1 is 1, so I'm just going to take this equation and I'm going to put the values in. So what you're going to end up getting is that f of x, the generating function, is equal to, it's going to be, so a times f1, where am I? Okay, a times f1, that's going to be 6, and then so you're going to have 6x over 6 minus 5 plus 5x plus 1x squared. And so if you look at what is f of 1, the reason why we're looking at this is because this is the sum of all of the numbers here. This is just going to be 6 over 6 minus 5 plus 1. And so 6 minus 5, that's 1 plus 1, so this is 6 over 2, so this is 3. So these numbers all add up to 3.